Science does not give up its greatest secrets all at once. It reveals them slowly, carefully, one extraordinary clue at a time. For more than 50 years, astronomers knew the first stars existed. The math demanded it. The physics required it. The entire history of the elements in the universe pointed back to them. But seeing them, actually detecting their light across 13.5 billion years of cosmic time, seemed forever beyond reach. And then the James Webb Space Telescope was built. And then it found Hebe. A tiny, pristine object near the ancient galaxy JWST, glowing with doubly ionized helium, carrying no metals, existing exactly where theory said the first stars would be, confirmed in April 2026 by two independent research teams using the highest resolution spectroscopy Webb has ever performed. The analysis favors a top-heavy mass distribution for these first stars, with most falling between roughly 10 and 100 times the mass of the Sun, consistent with predictions that the first stars were hot and massive, forming in a universe not yet enriched by heavier elements. Phys.org. The hunt is not over. But for the first time in human history, the trail is blazing hot. We are standing on the verge of confirming the very first chapter of the universe, and every new observation Webb makes brings another page into focus. If this discovery fills you with the same wonder it fills me with, the realization that we can trace our own existence back to a star that burned and died more than 13 billion years ago, subscribe right now. Because this is only the beginning. And I will be here every week, bringing you the next discovery from the deep sky. The reason these discoveries matter goes far beyond breaking scientific records. It goes to the very heart of what we are made of and where we came from. The population 3 stars were not just the first lights in a dark universe. They were the universe's first chemical factories, and without them, nothing we see around us today would exist. When these colossal first stars exhausted their hydrogen fuel and exploded as supernovae, they did something extraordinary. They took the pure hydrogen and helium of the Big Bang and, inside their blazing cores, fused it into the first heavy elements. Oxygen, carbon, iron, silicon. All forged in the nuclear furnace of a population 3 stars core and then blasted into space by its explosion. Those elements enriched the clouds of primordial gas that remained, allowing the next generation of stars, population 2, to form. Population 2 stars made more heavy elements. Those in turn seeded the clouds that formed population 1 stars like our Sun, surrounded by rocky planets made of carbon and silicon and iron. The oxygen we breathe, the carbon in our DNA, the iron in every blood cell in your body, all of it traces back through billions of years of stellar recycling to a single original source, a population 3 star that burned and died before Earth even existed. The ultraviolet light from these first stars split hydrogen atoms back into electrons and protons, ionizing them, ending the cosmic dark ages and making the entire universe transparent. NASA science, they did not just light up the cosmos. They built it. And now, for the first time in human history, we may be looking at them. But Hebe near JWST is not the only piece of evidence now pointing toward the universe's first stars. In October 2024, a completely separate research team led by Dr. Eli Visbal of the University of Toledo published findings in the Astrophysical journal Letters reporting what could be the most direct candidate for population 3 stars ever observed. The target was a distant stellar cluster called LAP 1b, a system so faint that even Webb's extraordinary sensitivity would not have been enough to detect it on its own. But the universe provided a helping hand. Sitting between Earth and LAP 1b, at a distance of 4.3 billion light-years, is a massive galaxy cluster called MAX J0416. The gravitational mass of this cluster is so enormous that it warps the fabric of spacetime around it, bending and amplifying the light from everything behind it, exactly as Einstein predicted in 1915. The team needed both the sensitivity of JWST and the 100 times magnification from gravitational lensing from the galaxy cluster between us and LAP 1b. Without that combination, the discovery would have been impossible. Space.com. Through this cosmic magnifying glass, Webb observed Lap 1b as it was 800 million years after the Big Bang. And what it found was breathtaking. Groups of stars surrounded by gas with almost no heavy elements. The chemical composition was incredibly primitive, closely matching theoretical predictions for what a young cluster of population 3 stars, or their most immediate descendants, should look like. The cluster also sat inside a small dark matter halo, exactly the kind of cradle our models say the very first stars would have formed in. Team leader Visbal stated, "If indeed the stars of Lap 1b are POP3, this is the first detection of these primordial stars." Space.com. Then, in March and April 2026, everything changed again. Maialino's team returned to GN-Z11 with Webb's highest resolution spectrograph and observed the helium-glowing clump again, this time with dramatically better data, and what they found was published in 2 companion papers that sent shockwaves through the astrophysics community. Deeper JWST observations revealed that the helium signal is real and resolved into 2 distinct components. In their separate study, Rusta's team independently detected a hydrogen emission line from the same location, providing a second anchor for the identification. Phys.org. The scientists gave this extraordinary object a name, Hebe, named after the Greek goddess of youth, daughter of Zeus and Hera, which is a perfect name for what may be the youngest stellar system in the history of the universe. The Hei emission has an extremely high equivalent width greater than 20 angstroms. No metal lines are detected. Population 3 stars are the most plausible explanation for the observed He2 emission, with no satisfactory alternative from other classes of sources or mechanisms. Arxiv. No metal lines detected. 0. This means the object called Hebe contains no carbon, no oxygen, no iron, no silicon, nothing heavier than helium. It is chemically pure. It is exactly what the universe looked like before a single generation of stars had lived and died. And the helium inside it is being ionized by something producing radiation so powerful, so extreme, that only one class of objects in all of modern astrophysics can explain it, a cluster of population 3 stars, still burning, embedded in pristine primordial gas, just as theories predicted for over 50 years. This is the strongest evidence in the history of astronomy for the universe's first stars. The story of finding the first stars begins with a galaxy called GN-Z11, one of the most extraordinary objects in the known universe. Located in the constellation Ursa Major, it was first discovered by Hubble, but its true nature was only revealed when Webb turned its infrared instruments toward it. GN-Z11 hosts a 2 million solar mass supermassive black hole in a very active phase of consuming matter, which is why it's so luminous. Webb. It is seen as it was just 430 million years after the Big Bang, when the universe was barely 3% of its current age. But it was what lurked in the halo surrounding GN-Z11 that would change the history of astronomy. In 2024, Professor Roberto Maialino's team at Cambridge pointed Webb's NRSpec instrument, its near-infrared spectrograph, at the halo of GN-Z11 and detected something that made them stop breathing. A tiny clump of gas glowing with an extraordinary helium emission line. Not helium from stars with metals mixed in. Pure, pristine helium, doubly ionized, meaning every electron had been stripped from every helium atom by an absolutely ferocious blast of ultraviolet radiation. Maialino stated, "The fact that we don't see anything else beyond helium suggests that this clump must be fairly pristine. This is something that was expected by theory and simulations in the vicinity of particularly massive galaxies from these epochs, that there should be pockets of pristine gas surviving in the halo, and these may collapse and form population 3 star clusters." Webb. The only known objects capable of producing ultraviolet radiation that intense, in a region with 0 detectable metals, were the first stars themselves. The fingerprint had appeared. And the search was on. Scientists named the universe's first stars population 3, and the naming tells a story. The stars you can see in the night sky, including our own sun, are called population 1. They are rich in what astronomers call metals, which in astronomy means every element heavier than hydrogen and helium, including carbon, oxygen, iron, nitrogen. These elements were forged in stellar cores and scattered into space by supernova explosions over billions of years, enriching each new generation of stars. Population II stars are older, found in the ancient regions of galaxies, and contain far fewer metals. They are billions of years old. But population III, the very first stars, had no metals at all. They could only have been made from the primordial ingredients of the Big Bang itself, pure hydrogen and pure helium. And because they lacked heavy elements, which normally help gas clouds cool and fragment into smaller, lower-mass stars, the first clouds had to collapse into colossal, extreme objects. We are talking about single stars potentially hundreds of times the mass of the Sun, burning at temperatures of 100,000 degrees or more, shining with the combined light of millions of ordinary stars. They burn through their fuel in just a few million years, cosmically speaking, a blink of an eye, before exploding as some of the most powerful supernovae the universe has ever seen. That short lifespan, combined with their extreme distance of over 13 billion light-years, is precisely why they seemed forever beyond our reach. Every telescope built before Webb simply lacked the power. Until Webb. To understand why this discovery is so earth-shattering, you need to understand what existed before the first stars, and the answer is nothing. After the Big Bang, the universe went through a period of intense heat and chaos as subatomic particles slammed into each other at nearly the speed of light. Then, about 380,000 years after the Big Bang, as the universe expanded and cooled, protons and electrons combined for the first time to form neutral hydrogen atoms. For the first time, light could travel freely, the universe became transparent. But there were no sources of light. The emergence of these first stars marks the end of the Dark Ages in cosmic history, a period characterized by the complete absence of discrete sources of light. Understanding these first sources is critical, since they greatly influenced the formation of later objects such as galaxies. NASA science for perhaps 100 to 200 million years, the universe sat in this profound and total darkness, a universe that was clear but completely empty of light. There were no stars, no galaxies, no warmth. Just an ocean of cold hydrogen and helium gas drifting silently in an expanding void, threaded through by invisible webs of dark matter pulling everything ever so slowly together. Theory predicts that the first stars were 30 to 300 times as massive as our Sun and millions of times as bright, burning for only a few million years before exploding as supernovae. The energetic ultraviolet light from these first stars was capable of splitting hydrogen atoms back into electrons and protons, ionizing them, ending the Dark Ages. NASA science these were not stars like our Sun. They were cosmic monsters. And finding them has been the holy grail of modern astronomy. For decades, they existed only in equations. Scientists gave them a name, population III, and built entire theories around what they should look like, how massive they were, how hot they burned, and how violently they died. But nobody had ever seen one. Not a single direct image. Not one confirmed detection. The universe's very first stars, the ones that ended the cosmic Dark Ages, forged the first heavy elements, and lit up a universe that had been completely dark for over 100 million years, had never been seen. They were the most important objects in the history of the cosmos, and they were invisible to us. Until now. In April 2026, 2 companion research papers submitted to the scientific community by a team led by Professor Roberto Maialino of the Kavli Institute for Cosmology at the University of Cambridge reported the strongest evidence in history for the universe's first generation of stars, observed through the golden eye of the James Webb Space Telescope, shining in a tiny companion object near one of the most ancient galaxies ever seen, just 430 million years after the Big Bang. This is not theory anymore. This is not a simulation. This is light from the universe's firstborn stars finally reaching us across 13.5 billion years of cosmic time. And what it is telling us about how we all got here is more extraordinary than any scientist dared to predict.